Berlin. And as you can see, this talk will be about the future of QML. And to get one thing out of the way right now, it will be only about the future of QML. If you are interested in when will there be a tree view in Qt Quick, then you're in the wrong talk, sorry. This will only be about QML, the language. Okay, and what will this talk be today about? Well, first of all, we will share our vision for QML in Qt 6.0. And the remainder of the talk will be about the path ahead, how we can arrive at this vision, and about some best practices in QML. Okay, so what is our vision? Well, it will be that we will have 3 different dialects of QML in Qt 6. One of them should be familiar to all of you. It's dynamic QML, and it's really the same as QML in Qt 5. And this is important. This will be fully supported throughout Qt 6. So if you are already happy with QML, you don't have to fear anything. Everything will still work. What will be new is the next dialect, which is strict QML. And that will be a subset of dynamic QML with the goal to allow compilation to C++. And that's currently our active focus for the Qt 6 development. Lastly, there will be static QML, which is an even further subset of strict QML. And you might already have heard of it because that's basically the part of QML which is available in Qt for MCUs. And for this talk, we won't really talk about that one because it's more a job for the Qt for MCU team. Okay, now a bit more about dynamic QML and strict QML, about the properties, the differences, and what it's all about. So dynamic QML, as you might know, it allows you all of JavaScript, at least everything that sits in the ECMAScript 6 standard. So you can have closures, you can have circular object references, you can have generators, all kind of fancy stuff. And you can do quite a lot of runtime. You have access to JavaScript's eval function. You can use create QML component to dynamically create components. And this is also what powers our QML preview tool, the QML debugger, and a few other nice features of QML. And this will become important later. It allows you all kinds of property lookups, like you can do unqualified lookups in the root scope. And there are context properties, which we will also talk later about. And with all the power come some requirements. For instance, dynamic QML requires a garbage collector because, I mean, you have circular object references, so you need a garbage collector. And because we allow all those kinds of lookups, we require versioning. And all of that also requires a full-time library to support QML, to support all that dynamic code evaluation. So there is a library with an interpreter. Static QML changes a few things. First of all, it will restrict the part of JavaScript which is supported. So there won't be any circular object references anymore, which directly leads to the fact that there won't be any closures anymore. Like you can only have functions returning objects or simple types. And you probably will be required to add some type hints to your functions, like you might know from TypeScript. There will also be no runtime compilation anymore. And instead, the code will be compiled to C++. And you will be able to use your normal C++ debugger like GDB. Furthermore, there will be some restrictions to property lookup. So there won't be any context property lookups anymore and no lookups in the root scope when they are implicit. And with such restrictions, we can get rid of the garbage collector and we won't need versioning anymore. And I mean, if you can get rid of the runtime with the garbage collector, well, you can get away with a lower amount of memory and you can reduce the CPU footprint. Okay, so that's the high-level goal of those dialects. Now, what's the time frame? What's the process? How do we arrive there? Now, first of all, this is still kind of in progress. So the exact distinction of the dialects is currently still emerging as we are writing the tooling for everything. And we expect it to take several minor versions of Qt 6 before the strict mode is completed. The dynamic mode is, of course, already usable as is because it's just the same QML as it's in 5.15. And as I told you, there will be the differences between these dialects. And if you want to opt into strict QML, we want to help you. And for this, we will add, of course, documentation about change behavior, about new restrictions. We will make sure that there are actually replacements for all the things you are doing currently in QML with some restrictions, like if you are really using all of JavaScript, well, no way that you can move to strict mode. But for the majority of simple user interfaces, you probably can go to strict mode. And we also add tooling support in the form of QML, which can report about incompatibilities in strict mode. And our goal is that you can gradually migrate your code over the course of Qt 6. And how does the migration path look then? Well, the idea is that already now, starting with Qt 5.15 and continuing with Qt 6.0, you can adopt best practices. And this will already gain you some benefits with dynamic QML, like better scalability. I come to that in the next slide. And this will also allow better tooling, and in some cases, it will already improve the performance right now. So what do you mean with better scalability? Well, the idea is that we can increase the readability for humans by ensuring that everything is declared in QML and that there's no ambiguity, and that there is more flexibility, that it's easier to reuse your components in different contexts. We will see in a few slides how that's achieved exactly. So what are the best practices in QML? Already now you can avoid unqualified lookups in the root scope. You can avoid context properties. You can now with 5.15 use required properties. You can declare your types declaratively. And if you do that, you can avoid versioning. Furthermore, we plan to add support for private properties and to have a better way to express group properties. I will now, in the remainder of this talk, show you exactly why these are best practices and how you can achieve it. So the first part is unqualified lookup in the root scope. What you can see here is a small example of a button, and it has some active property. And if you click on the button, then we just toggle that property. And everything works nicely. Now there are a few issues. The issue is on clicked handler, we simply wrote active. And it refers to the active in the root scope. But what would happen if we don't use import qtquick 2.0, but a newer version? And that one has a mouse area which adds an active property. Well, in that case, suddenly the active wouldn't refer to the one in the root scope anymore, but to that of the mouse area. And the button doesn't toggle anymore. Currently, we avoid this with versioning. Like you have seen, there's that import number 2.0. You know which properties existed there. And if you keep as that version, nothing new will be added. However, that also pins you down to that specific version. And if you actually need new features in a new version, you're out of luck. So that's not really a good solution. However, it has a very simple solution. You can just add an ID to your root object and do a qualified lookup. So now you have to write a bit more. Basically, you have to add the ID of the button. But in turn, you can increment the number in the import as you wish and use all the newest features. And you won't get any conflicts with property lookups. Okay. So how can you fix this in your existing code base if you have unqualified lookups? Well, since 5.14 already, we support it in QML. And if you are still keep working in dynamic QML, then you don't have to hurry because unqualified lookups will still work. But when you are working in static or strict QML, unqualified lookups will be forbidden. And now to show you how QML actually works, let's check a small example. So we have, again, a small QML file. And it's basically the same structure, like we have some property in the root scope, in this case message, and in the on-click handler, we access it. Now we can run the QML tool, which is shipped with Qt. And run it on that file. And it will warn us about those unqualified accesses. Like here, you can see it detects that message is part of the root element. And then it suggests that we just add the ID. And you might wonder if QML can do that automatically. And unfortunately, currently it cannot. But it's on our task list to add that feature. Furthermore, if you look further down, there are also a few more warnings, namely about mouse. And if you check the file again, you can see that in the on-click handler, we are actually accessing some mouse property. Where does that one come from? If you have experience with QML, you of course know that in the on-click handler, you have access to the mouse object because it's inserted into the context. If you, however, are new to QML, this might be a bit confusing, like where does that mouse come from? So what QML lint suggests is that instead of using the code block syntax, you use instead a JavaScript function which takes a parameter, which we again call mouse, and use that one to make sure that the reader understands where the mouse comes from. And that example also leads us to the next best practice, avoiding context properties. In this example, the context property does not come from an event handler or a signal handler, but is inserted via C++ in the main.cpp file. So basically there's some advanced property which we insert into the root context, and in the QML file we access it. And if you run that example, everything will be fine. Well, at least if you really use that exact example. If you, however, use just the QML file and use it in a different project and forget to set the context property, well, you get a reference error at runtime, which is not that great, but well, you could say just don't forget to add the context property. However, there are more issues. And in this case, you wanted to use newer features from Qt Quick, so you imported version 2.10. Unfortunately, in version 2.10, the text element gained an advanced property itself. And in that case, even though you set the context property in the C++ file, it will still not work because the local lookup will shadow the context property. Not so great. So what is the problem here? Context properties are not declared in QML. they come from some outer context and are normally inserted by C++. Set context that we require is not visible if you only look at the QML document. And it's quite easy to shadow these properties with properties from the current element. So how do we avoid this problem currently? Well, again, versioning. If you pin a specific version of your imports, then you don't get newer properties and you can avoid this issue. And you have to basically ensure that your QML code is either only used in the original context or that you always keep track of the context properties that you need to set. That again is not really a decent solution. So how can we fix this? Well, one easy way is to just declare the properties that you actually need in your QML file. And then instead of just inserting properties into the root scope, you set those predefined properties from C++. So the solution is like if you have some shared settings which you want to access everywhere in your project, then you can just put them all into some object and use either you can register that object as a singleton in QML. We will see how both of those methods work. So if you want to set some properties of your object, you can use the family of set initial properties methods. In this case, we are using QML application engine, but it also works with QQuick window and with QML component. So you have some QML file and it has like a property number and maybe some text. And you want to set their values from C++. And then you can just say, okay, set those initial values to the values you desire. And I'd like to point out this only works with the top level component in your file. You can do this with nested objects inside of it. However, in some cases, this is all you want. For example, consider setting the initial geometry of a window when you create your application. If you, however, want to access your properties in multiple files and not only in the top level component, then you can consider using singletons in QML. So what can you do? You can just create a class which has the required properties, like in this case, text. And if you have an instance of it and you only use one QML engine in your application, then you can use the QML register singleton instance function, tell it which should be the module name and the version of the singleton, and make that object accessible to the engine. And then in your QML file, you just do the import of that module, and you can then access the singleton and access its properties. And if you have multiple instances, if you have multiple engines, you should probably rather use QML register singleton type, which takes a factory function, which can, by the way, also be a lambda. And that's how you can procedurally register singletons. We will see soon how you can do it in a different, maybe nicer way, declaratively. But so much about context properties. From the tooling side, they are handled the same way as any other unqualified lookups. It's just that QML won't have any idea where they are coming from. They will continue to work in dynamic QML, and they will be disallowed in strict QML and in static QML. Now there is one place where you often encounter context properties, And you might wonder how we handle set. And set place is our model and delegate classes. So what we see here is a view and some model. So we have some list model with list element, and it has label. And how do we display that label in our view, which in this case is a repeater? Well, it's accessible as a context property in the repeater if you're using the correct model. Didn't I just tell you that context properties are kind of bad? So one issue is that you can only catch this at runtime if your model doesn't match the desired shape of your view. Like if you use 12 as a model, there won't be any text property, and this will just cause a reference error. And what's even worse, if you have a label property somewhere else in the scope, that one will be found, even though the model doesn't really provide it and it probably wasn't intended that label is found in the text. So how can we fix this? Or first of all, what's the problem? So what we really want to do is to access some model data in our delegates. However, our delegates don't really know how our model will look. So how do we currently avoid this issue? Well, the model data is passed as context properties and the delegate accesses those. As you can imagine, after the description of context properties in the last section, we don't consider this a decent solution. How can we fix it? Well, with Qt 5.15, we introduced some new feature called required properties. And with those, we can basically specify what the delegate is expecting. So what we can do is we say our delegate has required property called label. And now we are not using any context properties anymore, but instead checked the model for the existence of such a role. And in the case of this model 12, which doesn't have that label, we create an error message and won't find that label, which is probably the right thing in this situation. And furthermore, required properties are not limited to model and view classes. That would be a bit over-specific. You can also use it in any other context. Like you can create you can add them to just any element. And the QML runtime will check that required properties are set correctly. So if you set a property, everything will be fine. And if you don't do it, you will get an error. And unless this component is created dynamically, you will even get this at application startup time. So you can quickly find any issues relating to non-Z required properties. Okay, so to sum about required properties, they give you a nicer way of writing delegates, which makes your intent clear. They can potentially be checked at compile time when we are changing over to strict mode, and they are available since Qt 5.15. So next topic. We already talked about singletons, and there is a whole family of QML register type functions. They are all used to expose C++ objects to the QML engine, and the basic structure is, okay, you have some type like my type, which you want to expose to the engine. So you call QML register type, pass that class as a template parameter, provide the URL, the major version, minor version, and the name of the element. And then you can use it in your QML. And if you're using our tooling with Qt Creator will magically learn about the type in the QML files and offer you niceties like code completion. Magic. At least as long as it works. Unfortunately, it doesn't always work. So the first issue is that not all of our tooling is Qt Creator. For instance, if you use QML you will soon run into issues. Why? Because QML has no idea about the C++ code model, so it has no idea what my type is referring to. Furthermore, even Qt Creator's code model is not perfect. If you have some conditional code passes and do not always register the type, you might get false positive. So the code model thinks that the type is available even when it's not. And on the converse, if you don't use a string literal to pass it to QML register type, but instead some complicated expression or some variable from somewhere else, since the code model won't be able to correctly populate the QML code model anymore. Not so nice. So how can we solve that? And what's the problem? Well, the problem is that our register type functions are largely invisible to tooling. That makes it impossible to verify the compatibility of the registered C++ types and the QML code. And it hinders our tooling. Like you cannot do compile time analysis of QML documents very easily, and you cannot implement a language server easily. So how do we avoid it? We could implement the heuristics from Qt Creator in all of our tooling, or we could just give up on it, but that's not really a solution. So how did we fix this issue? Well, the idea to fix it is to use a declarative way to do the class registration to QML. And then we can generate some meta information from this registration, and our tooling can use that data to provide all the niceties that you expect. So how would this look like? Well, here we have a header file, and in it we have our myType class. And what we can do is we just say it is a QML element. And that's all our tooling will need. The only other thing is if you have a QMake project, then you will have to add QML types to config, which tells mock to basically create a QML types file. And then you have to also specify the import name, because there must be some way for our tooling to know how the module should be called. And you also have to provide the major version. You do not need to provide any minor versions. Those will be generated automatically if you have revisions in your object. And this does not only work with QMake, but it also works with CMake. At least that's what I would like to tell you. However, it only will work with Qt 6 in CMake, because unfortunately we needed newer features from CMake which weren't available when Qt 5.15 was released or is going to be released soon. However, with Qt 6, you also can do it with CMake, as you can see here. And while it's not officially supported by the Qt company, I'd like to do a huge shout out to the Qubes community, which added support for this already in the current version of Qubes. And it already works with Qt 5.15. So great jobs, guys. And let's give you a short example how this works and how this helps you or helps our tooling. So this is an example project from which is shipped with Qt. There's some simple class which has some properties, and we say that it's a QML element. And we have an example.qml file where that class is used. And we do an import here to have it available. And if I currently use QML lint, it will tell me that it has no idea what that person is and ask me if I added all import paths. So because we now are using that declarative type registration, I can now run make to compile it. And once that has finished running, there will be a new file called adding.qml types. That one is generated by the build system, or like more specifically by the QML type registrar, and it describes the class. So it's available for tooling. And if I now run QML lint again, it can use that information to know about the registered type, person, and won't complain anymore. Okay, so much for this. Type registration from in this style is quite nice. It improves toolability. You can use it starting from Qt 5.15, and for strict and static QML, it will be required because there we need to do more compile time analysis, and for that we need set data. Okay, next topic. When we were talking about lookups, I already mentioned versioning. Actually, that's the exact same example from the slide of the lookup in the root scope example. And I told you that we have to use provisions so that that one's property doesn't shadow the property the user declared. Unfortunately, that's not enough in all cases. Like, as soon as you use some indirection, like you want to use not our normal text element, but a native text element, which just sets the render type to native rendering. And you import QtQuick 2.12 there, because why wouldn't you? There doesn't seem to be any reason to not do it in this file. You will run into issues here. Even so, you import QtQuick 2.0 in child.qml. It will still use the text from 2.12 in native text QML, and it once will be available there. And so the lookup here will give you the wrong property. However, that's only the case if you use unqualified lookups. And as we told you before, that's actually not a good idea anyway. So if you consistently only use qualified lookups, those version numbers become quite irrelevant because they only were meant to protect from those kind of lookups. So what can you do? You can actually just omit them. And in that case, you just always get the latest version of Qt or whatever else you import. And because you use the latest, and because you always use qualified lookups, you never run into the issue with the lookups finding the wrong property. Great. And we also plan to allow dropping the major versions in QML, because unless you have something like Qt controls where there is a huge difference between 1 and 2, you might not actually need a major version number, like for your own code where you actually control everything you're doing and don't have those backward compatibility issues. So just save a bit of typing and do a versionless import. So in Qt 6, minor versions will be certainly optional, and maybe even major versions. QML will even flex those imports with minor versions because you can just omit them. And in strict QML, there will be no support for minor versions, and the same will probably hold for static QML. Major versions are still a bit under discussion. Lastly, some nicety, private properties. There's currently a problem in QML that you cannot really hide anything in your QML components. You can even access it in terms of sub-objects. And if you ever heard something about encapsulation, that isn't it. So in practice, this leads to quite some ugly code where we use underscores or JavaScript closures to hide properties, or we just ignore the problem and tell our users to just not access those internals. And that's not really a nice way to handle this. And the idea is that in Qt 6, we will add a private keyword, so you can just mark your properties as private and they won't be available in outer contexts. This is currently not implemented, but something which is clearly on our roadmap for Qt 6.0. So they are planned for Qt 6, and when they are available and it makes sense, please use them. And that's basically all from me. I hope this update on the future of QML and on our best practices was helpful for you. You can check our blog post for posts tagged with QML. There are already a few about new features in 5.15, and I expect that there will be more blog posts about upcoming changes. If you have any questions, we will now have the Q&A session. And as a reminder, there's also a survey about this virtual conference, and we would be very glad if you could fill it out. Thank you. Okay, we have quite a few questions in the Q&A session. So the first question is if you can do if-def in strict QML. Currently, this is not supported. However, we know that people really want this feature, like if you have conditional code depending on the platform, like for Android or for Windows specific features. You can currently use in dynamic QML, you can use file selectors and loaders to do some hacking there, but we are still investigating conditional compilation in strict QML. So there is a question why we are removing context properties, and that they are useful in certain cases. I would agree with this. However, they just make tooling basically impossible, because our tooling just cannot know where these context properties come from. And you run into all those lookup problems, which I showed in the slides. However, if you really like them, you probably just have to use dynamic QML and live with the issues that arise there. The next question is about live reload in strict QML. And the question is, does strict QML allow live reload? Well, currently it's not really finished yet. So the answer is certainly no as of right now. However, like the question also suggests, you can use just dynamic mode in QML for developing and debugging, and then just do a release build with strict QML. That's at least the idea we have. And that should allow, that should give you the best of both worlds. Yeah. And because strict QML is supposed to be a proper subset of dynamic QML, this should always work. The next question is whether Qt Creator has an option to show the warnings about unqualified properties. Unfortunately, currently it doesn't. There are plans to integrate the functionality from QML into Qt Creator, but currently it is not ready. The next question is, in dynamic QML, why don't we report ambiguity for unqualified lookups? There are two reasons for this. The first one is that in most projects currently, that would cause many, many warnings, because nobody really took care of this before. And the other one is to find out about ambiguity. You have to traverse all of the scope chain and cannot stop anymore when you find the first property. So this would actually have a runtime cost. We might add some debug option to QML, but I don't think there are any plans for that yet. The next question is, if the goal of QML is to flag all issues that would prevent usage of strict QML or static QML. Yes, that's certainly one goal, but it should also help you with other issues. Like in Qt 5.15, we deprecated some API related to local handling in QML, because this reflects a change in C++ local API. And also those kind of deprecations should be handled by QML. So even if you want to keep dynamic mode, QML should be helpful there. The next question is if there is any plan on releasing a detailed QML specification, a language standard. Well, we were working on this, but to be honest, it's quite a lot of work. I expect that at some point we will have such a thing, but it takes quite a lot of work to specify everything in a formal manner. And I think before we have a formal QML specification, we will probably have something like a test suite, which checks for conformance with a non-existing spec, but like with the expected behavior we have in Qt. The next question is about the use of required properties in delegates. Whether it is recommended to already use them everywhere in 5.15, and whether they are required in strict QML. So I certainly would recommend to use them already now, if you only have to support Qt 5.15. Something which I did not show on the slides is you might know that in delegates you can also access a model property and then do model.role instead of accessing a role. And if you really don't want to write all those required properties because you have quite a lot of properties, then you also can just use required property model and still do those accesses via model. So that might be a compromise there. However, in that case, you won't have all the type information that you would get if you declare all properties as required. And I would strongly suggest to at least declare model as a required property, even if you don't use everything else, because in that case, you won't have any model context properties in your scope, which can prevent some confusing bugs. The next question is about whether QML element can be used in place of QObject. No, that was just because there was not enough space in the slide to have both macros there. You have to use both QML element and QObject, or you use QML element and QGadget because you can also register QGadgets. The next question is about Python support. My answer is currently there is no declarative type registration support in Python, but just today I had a talk with the Qt for Python team, and we are actively exploring what we can do there. The next question is, why does QML element has no module and version parameters? Well, the idea is that set information is provided in the build system. And in QMake, that means that you have, if you want to have multiple modules in one application, you will have to use multiple .profiles because there it is done on a profile level. However, in CMake, those properties are set at the target level. So you can just create multiple targets and then just links everything together into your application. You can do all of this in the same file. CMake file. And this might be a bit nicer in that case. So next question is, what if you want to use a specific version of a component in strict mode? Because I said that there won't be any minor versions available there anymore. And my answer is, why would you want to do that? Currently, the versioning is only to basically avoid those property lookup clashes. And if you want to require at least some specific version, you can just, well, actually you cannot do that in all cases. You can do that for Qt libraries by just using a Qt required minor version. For your own files or your own libraries, I currently don't see a solution for this, and I think we will discuss this in the team if this might be required after all. The next question is whether strict QML components can be used in dynamic QML, and whether Qt quick controls too will be ported to strict QML. The latter, the answer is that's our goal. It won't happen, however, in the Qt 6.0 timeline. I expect this to happen in later versions of Qt 6. And however, the first part, can strict QML components be used in dynamic QML? Yes, of course. First of all, strict QML is anyway a subset of dynamic QML, so that should always work. And also, we don't expect to have an engine-free, garbage collector-free version of strict QML already ready with Qt 6.0. But we expect to have some initial support for compiling singular components to C++. And the idea is that you can then use those in other places in your dynamic QML project. The next question is, how will you switch between dynamic and strict mode? The idea was that this can basically be indicated by a pragma statement at the top of the file. But honestly, that's not decided yet, and we are still investigating what would be the best way to do this. The next question is, was it ever considered to make properties private and read only by default? And the answer is no, because it would break too much code, like it breaks even our own code in so many ways. So we can't impose that to our users. The next question is whether strict QML will support attached properties, and I don't see any reason why it shouldn't. So that should still work perfectly fine.
I think we have time for a few more questions, but unfortunately we'll probably run out of time. Yeah. But yeah, we've got a few more.
There are more questions from you than I can answer in the talk, but we have our other channels and we'll try to answer as much as we can. So the next question, again, about attached properties. Can they also be required properties? I currently don't think that this is possible. If you have a specific use case for this, maybe report a feature request in our bug tracker so that we can discuss this in more detail. The next question is, how long will dynamic QML be supported? At least as long as Qt 6 will be supported. And honestly, I don't see dynamic QML going away. We need it for live preview. We have some customers which want to use all of those JavaScript features. And yeah, I don't see dynamic QML going away. It's just that static QML, strict QML will allow you a different set of trade-offs to gain a few advantages.
Okay, I think that was unfortunately all the time we have for today. But thank you, Fabian, for the very informative session. Please send us or give us some feedback by filling in the survey at qt.io/thankyousurvey. You can also join the next live session via the live event page. If you'd like, there were some questions that we didn't get to cover, so we'll follow up on those. Or if you'd like, you can also now tune in with the live chat or with Qt Professional Services on the live event portal as well. But thank you again for joining. Thank you, Fabian, for your presentation, and have a good evening and day.